Hello, my name is Finn Hubwitz, and today I have a special guest with me named Connor Lardy. Connor is a very advanced architect, and we are very lucky to have him with us today.
Thanks you so much for having me here today. It is a real honor.
If you don't mind, I have some questions that I would like to ask you.
Yeah, sure, go right ahead.
How did you make the tower the required height? And how many note cards did it take you to reach this requirement? How are the cards configured?
Well, what we did is we set in 3 pillars of 4 short note cards in order to get the required height. We used a total of 14.25 cards to reach the requirement. They were configured in straight columns with 4 short tubes stacked on top of each other with a 1/4 slip of paper in between each tube.
Describe how you use folds in your design to achieve strength and stability. Did you incorporate anything into your design to achieve this?
We used the technique of short tubes in order to achieve strength and stability because from our experiment we got a total of 24 newtons more than the nearest other tube of the short square. So our entire structure is composed of only these tubes in straight columns.
How did you cut costs without sacrificing stability? In other words, was there a way you minimized the cards with your project? How much did your design cost?
We minimized the cards by cutting a single card into fourths to slip in between each small circle tube, which overall brought it from an original total of 9 to 2 1/4 since we replaced the whole index card. These little slips in between didn't really do anything except keep it into place. The overall price of the design, since each pillar in real life is about $1,000, we put it down to $1 in an index card. So we had a price of $14.25.
Describe what part of your design was as successful as you predicted and what part was not.
We were able to hit the key points on the books that helped with releasing some of the pressure and allowed for us to be able to hold a lot of the weight for fewer note cards. We predicted this would happen. However, what part was not successful is that we made the tower fall was more of the unraveling of the card than the weight itself.
Was it worthwhile to double or triple cards for their added strength? And what was your calculated ratio?
For us, it was not worthwhile doubling or tripling cards because even though it supported more weight, it did not support enough weight for the number of extra note cards it used. The calculated ratio that we found compared to the weight is 0.7 to 1 for our most amount of weight we were able to carry for both.
What difficulties do you anticipate in completing the first quarter project?
Some difficulties were balancing the note cards perfectly on top of each other and balancing the books on top of these note cards, which made it incredibly unstable at some points.
In general, did tall or short shapes do a better job of holding weight? Why do you think that is? And what are the advantages and disadvantages of tall and short shapes when constructing a 30 centimeter tall tower?
Shorter shapes did a better job of supporting weight because they are more stable and have a lower chance of falling over. And so this is better for the 30 centimeter tower for more stability reasons. An advantage of the tall shapes is that they cover more space vertically, but a disadvantage is that they cannot support as much weight as the small shapes, so they crumple. This advantage of the small spaces is that they can support more weight without crumpling, but a disadvantage is that they cover less space vertically, and you would have to use more note cards to get to 1 foot.
What physics concepts are addressed in this video, and what material in class ties into the skills needed to complete this project?
Some physics concepts that apply to this are balanced and unbalanced forces because they are balanced forces when the note cards can hold up the weight and the books are unbalanced when the note cards can't hold up the weight of the books. Some material in class that ties into the skills needed to complete this project is the concept of a static equilibrium, which discusses the idea of an object that applies weight down needs weight up to stay at a net force of 0 and not break.
Do you have any closing remarks before we end?
Yeah, hire us for this new building project. We will not disappoint. Our buildings are sleeker than ever and the stability is stronger than others. You won't have any complaints.